Recording in progress.
Good morning.
Good morning.
So, are you ready to answer?
Yep, of course. I think it could be better if I show you some presentation of my work. It's not English presentation, but it's some.
It will ease our comprehension, right?
Yeah.
For so technical aspects, or yeah.
So, I gave you permission.
Yeah, you see.
Yes.
My coursework called like application of generalization principle of solving fuzzy matrix games. It's like in sphere game theory, and the main idea of my work is we have like simple matrix game of two players who play each other. One first player want to maximize his income, and second player want to minimize his income, and that income shows in something like that matrix. Because of that game with zero sum, we have only one matrix with only values in it. But it's nothing interesting in this task, because we already solved it like scientists years ago. But I added or additional to this task. I solved some another game named fuzzy matrix game, that we have instead of these real numbers, we have fuzzy numbers. And to easier understand what fuzzy number is, it's like some probability of being number after that realization. For example, if we have number 1, 2, 3, 4, it represents that after number was realized, it could be from 1 to 4 value, and the most probability of value was from 2 to 3 value, if you understand, I think. Also, we have to solve for these numbers the matrix game. Solution for matrix game, it's like the most optimal solution for both players. We will find a mixed strategy of both players and the optimal value of the task. For this, we use something called like alpha cuts. If you see on this picture, we have alpha cut in half value, and this alpha cuts our number in the middle, and do it less. Like if we use this cut, we have from number 1, 2, 3, 4 to number 1.5, 2, 3, 3.5, and after that we change it number to the most worst value for both players. Like if we solve a task from perspective of first player, we represent this number as 1 and 1.5 because we need to see the worst result from first player. And also, if we solve from second player, we choose 3 and 5. After that, we represent this fuzzy matrix to simple matrix with real numbers, and solve task with that real numbers. Using a system of inequalities, like solid, like in simplex method or in other methods, it doesn't matter. After that, we use so much this alpha cuts, like 10 or 50, what we want, and solve every subtask. And after we have this fuzzy number, but in the way of optimal solution. Okay, and we have some example of it. For example, we have input of data in this form, and after that we use some cuts, choose the value in these intervals, have the real matrix numbers, solve it, and have something like that answer. Also, for this task, I realized some program that you can see on my GitHub. If you want, I can also show you how it works, but it's quite simple. We have some input, have some calculations, and have some answer for it. Also, I draw some diagram for this answer. That's all for my coursework in this semester. I want to continue this in this sphere to in my future research. I want to extend this principle to use some not only fuzzy numbers but fuzzy strategies when we don't know already what strategy player should use in some cases. But I don't research yet quite a lot about this this way. Okay, I think that's all.
Are you a gambler, Denise?
No, I'm not.
You are not. You're a dangerous person, you see. I think that you should be put on a blacklister. And I think that so casinos should be warned there, yeah. Because you see, I'm a blank person, completely blank person in math. But what I get from your presentation is that you can count, yeah. And yeah, calculator, yeah. So yeah, the victory, which dice, right, will win, so to speak, yeah.
I think it could be used in this sphere, but mostly it used in economics, math, and some biological spheres.
Yeah, but so this aspect of your work is rather conspicuous for a person who is not very good, so in at math, yeah.
Usually, this is like sphere called decision thinking in uncertainty. Usually, if you solve some task, you need to find a lot of information.
Denise, you
I'm sorry. Are you here?
my internet connection is unstable, so
Okay.
I
As I said, usually you need to find the most description of your parameters and lots of information. But if you can't get this information, you need to use something like that fuzzy numbers, something accuracy or another.
Okay.
Okay, sounds like justification of what you've done.
Yeah,
Okay.
probably.
Yeah.
Does it help you to win the lotteries?
No, I don't use it yet.
Yeah, he will try to use it to play poker, for example.
Maybe, but I think exists better ways to play poker already.
Yeah, but I think that you have this quite good combination of psychological tricks, because you are a very calm person, yeah, and so mathematical tools are to calculate, so the future mover, yeah, of other players, so that's right.
The next.
Practical application can be hard.
Okay. So, Denise, will you leave for a while?
Yeah, okay, for sure.
And we'll invite you back.
Recording in progress.
So Denise, of course, you are so responsible student and attended all the classes. So nothing except 20 out of 20 we can suggest.
Yep, exactly.
No fuzzy numbers, just 20, you see, real number.
Yes, absolutely. See you soon.
Okay. Bye, Barry. I wish you good luck and good game.
Yeah.
In the
Denise,
future.
are you going to continue as a PhD researcher?
I don't know for sure because if it's if it will be so easy like now, I probably should continue, but I don't know for
Yeah,
sure.
for you it will be easier, so I advise you to
for you.
continue. Yeah.
For you, it would be.
Bye.
Bye, Barry. Bye.